Hello, everyone, and welcome to Biogas and RNG Online, the first virtual event connecting global leaders in renewable gas. Hosted by Biogas World, this platform brings together innovators, project developers, and solution providers, driving the energy transition forward. Today, we're thrilled to spotlight one of the most advanced biogas upgrading technologies in the industry, developed by Waga Energy. Based in France and expanding rapidly around the world, Waga Energy recovers landfill gas and upgrades it into grid-compliant renewable natural gas using their patented WAGABOX technology. Joining us today is Yann Pierre, Group Sales Director at Waga Energy. Yann has played a key role in deploying WAGABOX units and brings a deep understanding of the commercial and technical strategies fueling their growth. Yann, thank you for being here.
Yeah, thank you for having me. It's a pleasure to be part of this event.
We'll start today's interview with a couple questions on technical foundations, namely raw gas composition and design impact. I was wondering if you can describe the composition of raw landfill gas and explain how its three main constituents affect the design of your upgrading process.
Sure, sure. Of course, so the landfill gas is quite specific in terms of quality, of course, but also in terms of variability. And so we can have strong concentration of H2S and VOCs. But the reason the WAGABOX exists is the concentration of oxygen and nitrogen that are in the raw biogas, and that cannot be removed with just the membrane alone.
Okay, thank you. Keeping that in mind, what are some of the key innovations in your system that distinguish it from conventional upgrading technologies, particularly in terms of membrane separation and cryogenic distillation?
Sure. So the WAGABOX is a unique technology and is based on the two patents. So it's specifically designed to treat high air ingress, which is happening when you want to recover more methane from your landfill and preventing this greenhouse gas, to leak through the atmosphere. So our unique design can treat the air ingress up to 30% nitrogen in this biogas with nearly no impact on the methane recovery, which is in the range of 90%. So the process consists in removing the pollutant like H2S, water, VOCs, and then a membrane separation to remove the CO2, like everyone does in anaerobic digestion. But finally, we have a cryogenic distillation that separates the methane from oxygen and nitrogen to recover the methane in very high purity. So the methane transforms into a liquid at very low temperature, while oxygen and nitrogen stays in a gaseous phase. And that's how we make the separation, and we can recover a very clean and nice RNG.
Wonderful, thank you. It's quite interesting how all this technology works, and I'm sure there's a lot of people and companies out there that are interested about the scalability. So with that in mind, what is the typical throughput range for a WAGABOX unit, and how do you scale your module system for larger landfill sites?
Yeah, so we have standard size of the WAGABOX units. We have 1,000 SCFM, we have 2,000 SCFM, and 3,000 SCFM. So these systems are standard. They are modular with different process function blocks that you can install further blocks in parallel if you want to scale up. Just remember that the gas production on a landfill is not flat. It's vary over days, it varies over decades as well. So you need to have redundancy, but also the possibility to scale up or to scale down the unit, and this is key. So beside that, standardization is also not helping to reduce the capex. Of course, it helps, but it also permits to have a standard spare part stock and to create an easier maintenance and an easy training of the operators. And that's really helped.
Wonderful. Thank you for that. Let's move forward and talk a little bit about energy balance. How efficient is a WAGABOX unit in terms of energy input versus RNG output? Can you give us an idea of electricity or thermal energy consumed per BTU of RNG produced?
So the energy efficiency of the unit is not much impacted by the quality of the raw biogas. And that's a key point for technology because that's make it very unique. But there are, of course, some slight variation. An important factor impacting the electrical consumption is the pressure of the gas grid you're going to inject into. But if you want a ballpark figure that works pretty much everywhere, you can consider that the electrical consumption is below 1/10 of the energy you will produce by the upgrading unit. So that's a ratio, and you can use it on whatever is MMBTU, megawatt hour, or gigajoule. That's the proper ratio. Also, maybe remember that we don't sell these units, but we sell the RNG. So we don't mind to invest in higher capex with much more energy efficient systems, but to reduce the OPEX on the long run. And that's really the mentality that we have when we design a plant for the sites.
You mentioned that you don't sell the units, rather you work with these partners. When Waga takes on the capital cost of installation and recoups investment through the RNG sales, how do you structure your offtake agreements and who are some of your key commercial partners?
Our business model is quite unique. So yeah, we decide to maximize the methane capture from the landfill and being rewarded on that performance and not just making a margin on selling the equipment. And it both protect our IP and also to ensure that the landfill will get the best dollar value out of that biogas. So in terms of selling the RNG, so we do have long-term contracts with at least 50% of the volume that we get on site for a price which is indexed on our production costs evolution, like electricity, maintenance, manpower. We always choose credit-worthy off-takers, and generally we have take-or-pay contracts, meaning that the off-taker is committed to take the volume that we deliver. The counterparts are either main energy supplier who purchase the RNG for then their own customers, like NG, for example. But also it can be some final user who want to decarbonize, especially in the transportation sector. So all that is done through the main energy suppliers. Other type of off-taker can be also for the compliance reason or voluntary targets, like the University of California, who set up some very ambitious target goals on the RNG to replace the fossil fuel. So that's different type of off-taker, but we can deliver to all of them.
Wonderful. That's so interesting that you have such a wide range of different partners and off-takers. And you mentioned the University of California. So we know that the European market is a lot more developed than the North American market, but we're starting to see a lot more growth there. What financing tools have been most important in accelerating your deployment, especially in North America? Have project finance, green bonds, etc., played a key role?
So of course, the business model is very cash demanding. I mean, we have internally at Waga Energy a team of 6 professionals worldwide covering the US financing as well, the relationship with the banks and asset management. So over the last 2 years, we have engaged with the financial sector, including banks, infrastructure firms, insurance firms, and financial advisor. In the US, so the first financing was signed with our long-standing partner, which is FL Investment Group, and in the form of a bridge loan of 60 million US dollar. And with that, we financed the construction of the first 4 WAGABOX in the US. And now we have a total of $350 million CapEx financing on overall Waga park of installation. In terms of tool, I mean, we have identified several financing instruments that could also accompany your project during the construction and the operation. So we have first bridge loans, which are very short-term loan and that needs a refinancing when the plant is then in operation. We also have mini perm loans that have short to medium maturities, like 5 to 7 years, basically, and that we will also refinance later during the operation of the plant. And then we have more traditional tax-exempt bond that offer low interest and very long maturities, but that can only happen when we operate the plants. Also in the US, the ITC, the investment tax credits, also had been a leverage as well to finance previous projects.
Yann, thank you for sharing these insights. We're very excited to see how WAGABOX continues to transform landfill gas into a high-value climate solution. That concludes all the questions that I have for you today. Just again, thank you for joining us. It has been a pleasure.
Thank you. It was a pleasure to share that journey with you.
Thank you to everyone who will watch this capsule and for tuning into Biogas and RNG Online, hosted by Biogas World. Stay with us for more sessions showcasing innovation across the renewable gas sector.